So good morning, everyone. My name is Henry. I am a PhD student here in CSIT. My research is on cybersecurity of PLC networks. And I would like to share with you my research on investigation on current PLC security issues. Before we jump into it, I would like to talk about what is a PLC itself. A programmable logic controller, or PLC, is a rugged device that is designed to be used under harsh environment. And it runs custom pre-programmed logic in a loop to control a physical process. They're used in SCADA system or industrial control system around the world. These devices are designed to be used in the field for decades before they ever replaced. And it used to be connected by serial connections. But since Ethernet come along and people connecting them to the internet, there is much more threat going on in these devices. Specific software and protocol are used to design and transfer custom logic to these devices. And usually, these type of software and protocol are proprietary to the vendor themselves. There is really a lack of knowledge to this type of information in the research community, which slow our research on cybersecurity in these devices. That's why the motivation for my research is to understand how this proprietary protocol works and also, if possible, identify the vulnerabilities for that so that we can finally start to do a more in-depth cybersecurity research specifically to these type of devices. There are few vendors in the industry, but we choose Siemens as our target for our research because they are one of the biggest vendors in the world. In fact, I think Northern Ireland's traffic light is controlled by Siemens. And also, the proprietary software that used to program these PLCs are called TIA portals from Siemens. And the protocol used to send the data across is called S7 complex protocol, or we call it S7 protocol. Since around 2015, there's a security mechanism built in. It is an anti-ripping mechanism consists of three parts: a S7 challenge, a S7 response, and also the integrity check. So to understand how this anti-ripping mechanism works and hence to find out whether or not there is vulnerability in this protocol, we have done a reverse engineering on the TIA portal itself. So what we're trying to do is when there's a S7 challenge come in, we try to see how the software calculate the S7 response. In a summary, the generation of S7 response is done in a very big function. It takes two different input which fit into two hashes, on which one of these go into a key generation algorithm and the other one go into some other byte generation algorithm. And all of them is fit into two encryptions, on which both of them are used, are part of the S7 response packet. Along with the S7 challenges, it is contribute into the calculations. What we have discovered is if we can manipulate the input of the byte to these hash algorithm using WinDebug, it is a debugging tool on which we can adjust the memory of the used by the software itself. We can generate keys that can be reused. Once these keys are generated, we can bring everything offline and run in a script. What it achieved now is as long as there is a S7 challenge when we start a session, we can generate a S7 response, which means we can start a session to a PLC whenever we want. The impact for that will vary, and I will talk about it soon. For the integrity check, it is similar. The payload of these packets are signed by two HMAC. The first HMAC calculate key for the second HMAC, which is a digital signature. No, it is a type of algorithm that provide integrity check for bytes. And the first HMAC generate keys for the second HMAC, while the second HMAC actually sign the packet itself. Similarly, we can also manipulate the keys for the first HMAC, which means we can reliably generate the keys for the second HMAC that used to sign the packet. So what we achieve right now is manipulate the S7 response, which we can start a session, and we can generate the key for the integrity check, which we can continue the sessions. So what all this means, ignoring what I have said for the technical things, is we can do a man-in-the-middle attack for session stealing, and also the denial of service attack on these type of controllers. I have a paper on this, and if you're interested, please have a look on that. And we can also turn on or off PLC with only 2 function packets, excuse me for the mistake there, and which means I can shut down the process itself. And I can perform a factory reset to the PLC, which means I can wipe completely of the PLC while doing all of that remotely. We are in the process of talking to Siemens on this specific exploit, and it's going okay, and they are still haven't get back to us after we have more information to them. And in CSIT here, we are trying to develop security mechanisms so that we can defend ourselves against this type of exploit in the future. And this is it for me. Thank you very much.